Let us now study about grazing incidence of light on an interface of two media. Now, we already discussed that if there are two media, mu2 and mu1, and if say mu2 is less than mu1, then in this situation the value of mu1 is high, so this is a denser media, and say from denser media if a light incident onto the interface at critical angle, where the value of critical angle is given as sine inverse of mu2 by mu1, which we can calculate. We already calculated by using Snell's law. Then after refraction, the light ray will graze along the boundary. This is the refracted ray which is emerging out at an angle 90 degree, and this we call emerging refracted ray. Now, one thing you must keep in mind that from a Snell's law we can say that during refraction, path of light ray is retraceable, which we call the law of reversibility of light. Always remember, law of reversibility of light is written as path of light ray in reflection and refraction is retraceable. That means if a light ray incident on this boundary from the side of refractive index mu2 at incidence angle 90 degree, then the light will refract at an angle theta c. So according to this law of reversibility of light, here again on this boundary, if an incident ray is incident on the boundary at an angle almost 90 degree, then it is refracted into the other medium at an angle theta c. And such kind of incidence on the boundary of any two media we call grazing incidence. Now, grazing incidence may take place either from rarer side of medium or denser side of medium. So there are two cases which we will study, and this is the case which belongs to the grazing incident from the side of denser medium, from the side of rarer medium, as we already taken that mu2 is less than mu1. Let's continue on the next sheet for both the cases in detail. Let us now discuss the first case, which is that of grazing incidence from denser medium. Say if there is a realistic situation in which there is a glass air boundary, obviously air is a rarer medium and glass is the denser medium, and from the side of glass a light ray incident on the boundary at approximately 90 degree angle of incidence, then here we can see the reflection angle will remain almost 90 degree and light ray will be reflected at the same angle. That means no light will get into the side of rarer medium or into air. So here approximate diagram for this situation we can draw like this. If this air and this glass, or if this rarer medium and this denser medium, and on the boundary if a light ray is incident from the side of denser medium, then the light ray passes undeflected, because here we assume that angle of incidence is 90 degree. So at every point the reflection angle will remain 90 degrees, so light ray will pass as it is if it is a boundary of two media and light is incident in a grazing fashion from the side of denser medium. Now if you just analyze on case 2, which is a situation we were talking about on the previous sheet, that is grazing incidence from a rarer medium. Now if you just have a look on this realistic situation in which again there is a glass air boundary, and if a light ray incident on the surface from the side of air, that is the rarer medium, then we can see the light ray will be refracted into the denser medium at an angle equal to the critical angle according to the law of reversibility of light. This is what we have discussed on the previous sheet also. if there's air glass boundary and if a light is incident in a grazing manner from the side of rarer medium, then after refraction the light gets into the denser medium at an angle theta c. So both of the cases you need to keep in mind that what will happen if a light ray grazes along an interface from the side of denser medium or from the side of rarer medium.